Let us look at proposition number 3 of works of Archimedes, specifically from measurement of a circle. The proposition says the ratio of the circumference of any circle to its diameter is less than 3 plus 1 by 7, but greater than 3 plus 10 by 71. Now, in the previous video, we have already seen the first part, that is, the ratio is less than 3 plus 1 by 7. Now let's look at the other part, which says that the ratio is greater than 3 plus 10 by 71. Okay, let's proceed step by step. Let AB be the diameter of a circle. Let C be a point on the circle such that angle BAC is equal to 1/3 of a right angle. 1/3 of a right angle is 30 degrees. And let's join BC as well. AC is to BC is less than 1351 is to 780. So here again he has taken one of the sides as √3, the other as 1, and the hypotenuse becomes 2. And he has taken this ratio in such a way that AC is to BC is less than this ratio. Bisect the angle BAC intersecting the circle at D. BC intersects AD at H. So let's mark the point of intersection as H. Now, angle BAD is equal to HAC. BAC and HAC means the same thing. So angle BAD is also equal to HBD. So let's join BD. So angle BAD is equal to HBD. Now, how does that come about? So let's briefly look at that. In triangle ACH and HBD, angle ADB is equal to ACH. And they are both right angles. Why? Because they are the angles subtended by the diameter or angles on a semicircle. Angle DHB is equal to CHA because they are vertically opposite angles. So in triangles, if two angles are equal, then the third angle is also equal to each other. So which means that angle HBD is equal to HAC. But HAC is equal to BAD. So that is how we arrive at this result. Angle BAD is equal to HBD. Okay, now that we have got this clear, let's remove this. Now, angle ACB is equal to ADB is equal to right angle. That means all these three triangles are similar to each other. And because they are similar, that means AD is to BD is equal to BD is to DH. Again, from Euclid, we know that in similar triangles, sides about the equal angles are in proportion. AD is to BD is equal to AC is to CH. AD is to BD is equal to AB is to BH. Now, which means since these two ratios are equal to AD is to BD, their sums, the respective sums of their antecedents and consequents will also be in the same ratio. So AD is to BD is equal to AB plus AC is to BH plus CH. BH plus CH is BC. So AD is to BD is equal to AB plus AC is to BC. Now, since AC is to BC is less than 1351 is to 780, AC is 1351, BC is 780. It is in this ratio. Now, which means if you divide 1351 by 780, you get root 3 is to 1. That means AC is root 3, BC is 1. And using Pythagoras, we know that then AB will become 2. So that means AB is to BC is equal to 2 is to 1, which implies AB is to BC is equal to 2 times what? 2 times BC. BC is 780. So 1560 is to 780. Okay. Now going back to AD is to BD. So AD is to BD, we have to figure out this ratio. So what we do is we use this ratio. AB plus AC is to BC. Now AB plus BC, AB is 1560, BC is equal to 1351, is to BC, which is 780. The issue here now is that this equality actually becomes an inequality because of this. So we end up with this inequality. Simplifying it, we get AD is to BD is less than 2911 is to 780. Now squaring, we get AB square is to BD square is less than 2911 square plus 780 square is to 780 square. Simplifying it, we get AB square is to BD square is less than 9082321 is to 608400. And taking the square root of this, we get AB is to BD is less than 30133 by 4 is to 78. So we have arrived at this. Now again we repeat. Again let AE bisect angle BAD meeting the circle at E. So let's mark that. Again following the above process, we get AE is to EB is equal to AB plus AD is to BD. AE is to BE. So let's join BE as well. Have we joined it? No. So BE. AE is to BE is equal to AB plus AD is to BD. Remember, we have to carry out these steps again because of the similarity of triangles. So, which means AE is to EB is less than 30133 by 4 plus 2911 is to 780. Because AB we know is 3013 3 by 4. AD we know is 2911. Where is AD? AD is 2911. And BD. So where is BD? BD is 780. Here comes the tricky part. AE is to EB is less than, remember this is a ratio. So if we multiply both the antecedent and the consequent by the same number, the ratio doesn't change. So here we are multiplying both the numerator and the denominator by 4 by 13. To get AE is to EB is less than 1823 is to 240. We are first doing squaring and then we are doing componendo. So that we get AE square plus BE square. AE square plus BE square, which is AB square. AB square is to BE square is less than 1823 square plus 240 square is to 240 square. And simplifying this, we get AB square is to BE square is less than 3380929 is to 57600. Taking the square root on both the sides, we get AB is to BE is less than 18389 by 11 is to 240. Again, we repeat this whole process again. Let AF bisect angle BAE meeting the circle at F, and then we join BF. Again, ensuring that we show that the appropriate triangles are similar, we arrive at this proportionality. AF is to BF is equal to AB plus AE is to BE. And AF is to FB is less than 3661 plus 9 by 11 is to 240. This 3661 9 by 11 is not appearing anywhere. So it has come about in the intermediate steps here, which I skipped because it follows the same logic. AF is to FB is less than 3661 9 by 11 times 11 by 40 is to 240 times 11 by 40. Now here again, both numerator and denominator are being multiplied by 11 by 40, which doesn't change the ratio. So AF is to FB is less than 1007 is to 66. Again, we square this and then take component of AF square plus FB square is nothing but AB square. So AB square is to FB square is less than 1007 square plus 66 square is to 66 square. And simplifying it and taking the square root, we get AB is to BF is less than 1009 1 by 6 is to 66. And let's repeat this exercise once more. Let AG bisect angle BAF meeting the circle at G. So again, following the same steps, we arrive at AG is to BG is equal to AB plus AF is to BF. AG is to BG is less than 2016 1/6 is to 66. Again, I've skipped some steps here. Squaring, componenting, we get AG square plus BG square is to BG square is less than 2016 plus 1 by 6 square plus 66 square is to 66 square. Now, AG square plus BG square is equal to AB square. So again, AB square is to BG square is less than, simplifying this, we get 4069,284 plus 1 by 36 is to 4356. And again, square rooting this, we get AB is to BG is less than 2017 1/4 is to 66. Inverting it, inverting the ratios, we get BG is to AB is greater than 66 is to 2017 1/4. Angle BAG is equal to 1/48th of a right angle, because remember we started with 30 degree, which is 1/3 of a right angle, and we have bisected that angle 4 times. So angle BAG is equal to 1/48th of a right angle, which means angle BOG is equal to 1/24th of a right angle. Because remember, again from Euclid, that an angle on the circumference is half of the angle at the center from a given segment. So that means BOG is twice BAG. So that is how we end up with angle BOG being equal to 1/24th of a right angle. Now, BG is the sides of a regular inscribed 96 gon. Because remember, again, we are looking at only one quadrant. Yes. So same thing would apply to the other three quadrants, which means 1/24 times 1/4, which gives us 1/96 of a complete circle. So that is how we end up with 96 gon. So now that means we have an inscribed polygon which is 96 sided. So perimeter of 96 gon is to AB is greater than 96 times 66 is to 201714. And if we simplify that, we get perimeter of 96 gone is to AB is greater than 6336 is to 201714. 6336 is to 201714 is greater than 310 by 71. So that means, remember, there is an inscribed polygon. So that means the circumference is going to be greater than the perimeter of the polygon. So which means circumference is to diameter is greater than 3 plus 10 by 71, which is what we had to prove. So in the previous session and in this session, we have taken each case one by one. And what finally we have arrived at is the range within which this ratio falls. And this ratio, circumference is to diameter, we call it as pi. So this is what we have proved. Pi is in between these two, 310 by 71 and 31 by 7. So 310 by 71 is less than pi, which is in turn less than 31 by 7. And if you look at this, if you convert it into an improper fraction, you get 7 3 is 21, 7 3 is 21 plus 122 by 7, which is what we use even today. So that is proposition number 3 of works of Archimedes, specifically from measurement of a circle. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.